This is our topic for today. We'll be talking about operators and expressions. Some of those, what we call operators, you guys are already familiar with from simple arithmetic and mathematics, like division and addition, adding, summing numbers or subtracting numbers. But we'll see all kinds of behaviors within the C# boundaries, how numbers behave, different kinds of numbers, like we've seen previously. There are all kinds of types that can store information. So we're going to see how those types correspond and how they react to different operations. This is the list of the operators that we're going to cover. We're going to start by displaying which operators are available and how they are preceding each other. We'll see the arithmetic options. We'll see how numbers behave with arithmetic operators. We'll see the logical operators. We'll see how they can correspond with Boolean values. We'll see the bitwise operators, which are a bit more tricky. We'll see comparison between values. We'll see how we assign values, which we've seen some of it in the previous lesson. And we'll see how we can convert from one type to another. Actually, I think that not everything is covered in this, but maybe I'll give you a few more examples. So let's get started. First of all, the definition. An operator is a symbol. Usually it's a symbol which we use to perform some changes in our data. For example, we can take two numbers and we can add them, or we can multiply them. So we have an operation for that. Or we can take, if we have a value which is Boolean, we could change its value from true to false or from false to true. That would be also some operator that makes the difference. Or if we have two strings, we can also combine them into one bigger string. That will also be done with an operator. We'll see examples of all this soon. We have three types of operators. It all depends on how many objects these operators are acting on. The most common ones are the unary and the binary operators, those that take one or two data objects. For example, we can take one number and we can increment it, or we can change the value by using only one operator. Or we can use one operator between two numbers. And there is also a third version, or a third option, which takes three different data objects and does something with them. This is quite less common, but we'll see an example, a very useful example of a trinary operator that takes three data values and works with the three of them together. This is a list of the common operators that are used. At the top we can see the arithmetic ones. Some of them are known to, many of them are known through simple mathematics, like add, subtract, multiply, divide. There's another one here which is calculating the remainder of a subtraction, of a division between two numbers. And we have two additional ones which take a number and increment it to the next number. If it is an integer number, for example, if we have 3, it will make it 4, and the opposite action which takes it and decrements it from 4 to 3, for example. We have the logical operators, which are operations between true and false value. So if we have some condition that we have to check, and that's quite useful in many scenarios in our programming session, we have to check whether one of them is true, or both of them are true or false. These are the logical operators that check or change the values. So we'll see all of them as well. We have the binary operators. These are a bit more tricky to understand, because we have to understand the structure, the binary structure of the data that we are handling. So if we have a number and we are doing some kind of binary operation on it, we'll have to know what exactly we're doing, because we're actually playing with the structure of the number itself, with how it's presented in memory with the bits of ones and zeros. So since these are actually since these are handling directly the binary information, those are binary operators, and sometimes they're called bitwise operations. We have comparisons, so we can compare data, whether it's equal, not equal, bigger, smaller. This is also part of the logical tests that we can check. We have all the assignments that we can, we've seen that when we were talking about variables, how we can take a variable and put a value into it. And we'll see all the other shortcuts here that appear in the assignment. We have this plus, which is the string concatenation that takes two strings and connects them. I think we've seen that also in part of the examples in the previous lessons. We have the type of, which is actually a word. It's not a symbol, but it's also used as an operator, and it gives us the type of the object that we are working with. And we have a set of other operators like brackets that are used in different places. We have this ternary operator of the question mark and the column that we'll see exactly how it works. We have the new, which is also a word, but it is also defined as an operator that creates new objects that you'll be using a lot when we'll be making classes. There's a list here of which operators precede others. That means that if they are in the same line of code and they are in the same statement, they are being executed, and you have a combination of those, you can see which ones are acting before the other ones. For example, we can see that multiplication and division is preceding subtraction and addition. This is just like regular arithmetic rules. There's a whole, this table is quite big, and it's actually a copy of a table from MSDN library, and I wanted to show you this table in the MSDN library further. We'll see it pretty soon. One thing to remember is that when you have parentheses, those regular round brackets, they're always coming first, and it's always smart to use them when you're not sure. And I can assure you that it's very useful to put parentheses whenever you have something which you're not certain of, or if you want to make sure that your calculation is done correctly, or anything which you are doing with Boolean values and calculations, or any combinations. If you are not sure, if you want to make this calculation be done as you want, always use parentheses. It's always better to use them than not to use them. So we'll start with the simple arithmetic operators, which are just like we said, the same in mathematics. We have the plus, minus, and multiplication. We have the division, which takes two numbers and divides them. We'll see how it behaves with the different types of numbers. For example, we'll see how it behaves with floating point numbers as opposed to integer numbers. If we have a division of numbers that has some kind of remainder, for example, if we divide 9 by 2, we'll get 4, and we have 1, which is a remainder. That's also an arithmetic operation which is supported, and that's the percent. That's what the percent is doing. Like I mentioned, the plus plus is also a useful operator which takes a number and increments it to the next. So here we have a few examples which we'll see also live. we have a variable here of type integer. We're setting its value to 17. Now we have a division of the 17 with the number 4, and we're assigning the result to another variable of type double. Then we're taking that result and we are multiplying it by itself. I think it would be better to see it in live and maybe to debug it and to see how these things act. So let's see what's happening here. Our first parameter is 17, and it's an integer. It's a round number. Our second one is a double number, and with the division we get a floating point result of 4.25. Once we take this result and multiply it by itself, we get again a floating point number of 18.60625. Here we have a printout of those two. Here we have two additional variables. Both of them are integers, 4 and 5. We can see the results of adding them, which we get 9. Now this is an interesting line. Oh, sorry. Oh, not working. Okay. What we have here is an expression. Can you see it? I'm trying to zoom into it. Okay. We have an expression here which takes A and B and adds them together just like before in the previous line. But we have another operator here, the B++, which takes B and increments it. There are two ways to increment a number, and those of you who've done C++ will know it as well, because it's the same. We have the option to put the unary operator of plus plus before or after the number that we're trying to change. So in this case, it appears after, and here it appears before. The trick here is that once we put the plus plus after the number, it will make the operation happen at the end of this statement. That means that first of all we have the addition of those two numbers, and then this operator will kick in. So we'll have the we'll have 4 plus 5, which are 9, and after that B will increment, and B will be now, it was 4, it will become 5. So after this line, B is already 5, as you can see. That's why on the next line we already have 5 plus 5, so the printout is 10. Now what will happen? Since we put the operator before the number, it will first make this operation take precedence, and that means we'll increment B first of all. So after this operation happens, we'll have B equals 6, and we're adding it to 5 again, so the result will be at the end of this line 11. Yeah, you can see it. The next line doesn't change the values of A and B, so it will be 11 again. Here we are dividing numbers. What we have here are two numbers which are integers. And when we are dividing two integers, the result will be an integer as well. If one of those numbers is a floating point number, the result will also be a floating point number. But in this case, we have two integers which are dividing, so we'll get the closest integer rounded. So here we get 3. Here we are getting the remainder of dividing by 3. That means 3 times 3 is 9, and the remainder is 2. And that's what we're getting here. Here again we have a division of two integers, but these numbers divide with a clean division. There is no leftovers. So at the end of this line we'll get 4. Two more examples of division. We are dividing here 1.5, but we are dividing by 0, which is an interesting case. Basically, division by 0, let me get back to normal zoom, and let's see a few examples of this. If we take and try to divide for example, okay, let's take two new integers. Oh, sorry. Oh. So since we are trying here to divide two numbers which are dividing by 0, once we try to run and we reach this line, we'll get an exception. Our program crashes and we get a notification that we're trying to divide by 0. Actually, if we are trying to divide by a literal 0 like this, if I put the number 0 in not a variable that can have different values, we won't even compile the program. We'll get an error during build. But what happens if those numbers are not ints, but they are floating points, and by default, the floating point numbers which are not specified are doubles? This passed. We didn't crash. We didn't get a division by 0. We managed to build a program. But we got here a value which says infinity. There are, since we're dealing with real numbers, floating point numbers have special values for infinity. And there are two values which we can see. We can address them if we go to double dot. There is positive infinity and negative infinity, and those numbers can be results of functions. So if you want to check, you can actually compare the result of a division to positive or negative infinity. So that will be the result here and here. So we got two interesting results. One of them is infinity, and the other one is not a number. That means that this division didn't produce any defined logical number. This is also accessible. This value is also accessible through double dot, not a number. So these are possible results of division arithmetic operations on different types of values, integers and floating points. Okay, so far? Okay, the logical operators. Those are usually operating on Boolean values, those that can hold true or false. And many times when we have a Boolean condition to check in our program, we have more than one more than one things that we would like to check. Usually if we have two conditions, then sometimes we'd want to check if one of them is true, or both of them are true, or both of them are false. So in order to combine them, we're using two operators, the and and the or. And there's another one, this one, which is called XOR, the logical operation XOR. This is the result of those operators. If we have or, that means that at least one of them has to be true in order to produce true. So if we have true or false here, one of them is true and the other one is false, we'll get a true. If we have AND operator, that's reproduced by the AND to 1%, then only if both of them are true, then we'll produce a true value. And we have the XOR here, which produces true only if the two values are different from each other. So one of them has to be true and the other has to be false, so we can receive a true. So if we have to check two conditions at the same time, we can take them into, put between them the or AND or XOR, depends on your needs. So here again is an example, and let's look at it live. So we're starting with Boolean values A and B, where A is true and B is false right now. So the first line checks A and B. That means we are checking both conditions of A and B. That means that both of them has to be true in order to produce a true value. And since one of them is false, then we'll receive false. Next we're checking OR. That means that if one of them is true, then the whole value is true. That could be checked. Of course, you can have multiple checks, not just two. You can chain many checks in your condition checking, and between them you can put complex structures of ORs and ANDs and XORs. All depends on what you need. Here's the XOR, which returns true only if both of them are different from each other, and that means that if one of them is true and the other is false, we'll have true. There's another operator here which wasn't mentioned in the slide, this exclamation point. Nope, not this one, this one. So the exclamation point takes a Boolean value and reverses it. So if we had in B false, here we'll have not B. This operator is usually referred as not, and not false is true, so we'll have true. The rest of the checks here are actually similar, except that instead of checking A and B, they are checking the values of A and B with literal value of true. So, not to get too confused, we'll just go over them. Here we had A as true, and we're using the exclamation point, the not again, so it will become false. And here we have a more complex checkup. I think we've seen the equal in order to check the value of a variable. So here we're checking if A is equal to B, and since they are different values, we can see that this operation produces false, so they are not equal. This operation checks whether 5 is greater than 7, and this produces also a false because 5 is greater than 7. And then we have parenthesis here to help us, and we take the result of this condition and the result of this condition, and we do a XOR between them. And since those two are similar results, here we have false and here we have false, then the result of the entire condition, not sure this will work, probably not. The result of the whole condition will be false because we're trying to XOR, and XOR is only returning whether the two are different from each other. Is that clear? Okay. Bitwise operations. So the bitwise operations, the basic bitwise operations, as you can see the table below here, pretty much looks like the previous table, because the actions that we're using here have the same effect. Instead of using double lines, those that represent OR, we have only one line here, one vertical line that represents the OR, but it represents the OR between two bits in memory. So the effect is the same. If we have OR between two bits and at least one of them is true, then we'll get a result of true. If we have a bitwise AND, which is represented by a single ampersand, and the result, and both conditions have to be true in order to produce a true result. In XOR, again, both bits have to be different from each other to produce a positive result. So these are usually used in order to make changes in the bit structure of a number. Are you aware of binary counting and how numbers are constructed in memory? Not sure there is an example here. For example, the number 3, which is represented in memory as 11. Anyone that doesn't know why? Okay, everybody knows how this works. Great. So if we have numbers here, and we are doing any bitwise operation, any of those operations that we've seen in the previous slide, they will have an effect on this single binary digit of each of the binary digits of the number. For example, if we take 3 and 5, like in this example, and we do an OR, we are uniting actually the bits which are ones, because whenever we have 1 and it's OR, and that whenever we have a true condition, at least one of the conditions is true, then we are getting a true result. So if we have 1 and 1, we get 1, and if we have 1 and 0, we still get 1. Is there someone? So these three operators are the same as we saw. They just take effect in the very small scale of the bits of the number, and that will work not only with numbers but with any memory stored that we have. Instead of using the exclamation point in order to get a negative of a certain number, we can use this tilde. And there are two other operations here which are specifically only for bitwise operations. Those are the two arrows to the right and two arrows to the left. And what they do is push the bit structure to the right or to the left according to the number that we are specifying here. So if we look at the original number of 3 here, which was the A, which had 11, we are pushing the bits to the left. So that means instead of 11, we'll have 110, and we're moving them one space. Actually, it's called shifting. And the number resulting here will be 6. Same as if we are shifting to the right and we have the 2 arrows going to the right and the number of bits to move. So if originally we had 3, which is 11, we're shifting to the right and we have 1 bit falling off, the result will be 1. So we're actually changing the value of the number itself. Even though we're playing with a binary representation of it, we're making changes in the data. So if we are making changes like this, we're shifting A to the left, and we get a 110, which is actually a binary representation of 6. This means that the result of this action will become 6, the number 6.
So the variable changes?
No, because we are not assigning it to anything.
Aha, okay.
But if we assign it, the value that we'll assign here will be 6.
The value in brackets. And if we assign the value in brackets.
Yeah, because this code only prints out to the console. But
okay.
So here is the demo. A and B are 3 and 5. And these are the results of the bitwise operations. We're not changing their values, but we can see the printout. Let's try to get it like this. No, too big. So A or B reproduced this result, which is 7, because we have 1, 2, and 4. Then we produce 1, because we're taking only the places where we have 1 and 1 only. So the production is 1, and we're producing the number 1. This is the XOR. This is the not A, and then putting the result of taking all the bits of A, transforming them to the opposite of what they were, and then taking this result and doing an AND with a B. So here we got, actually the outcome is this. Shifting to the right, to the left, shifting to the right, shifting 2 places to the right. So if A was 11 and we are shifting 2 places to the right, we are just losing the 2 ones on the right side. They are both dropping off, and the result is 0. Shifting 2 places to the left. This is the negative of A. That means all the values are being reversed. Wherever we had 1, we get 0. Wherever we had 0, we get 1. And this is a representation of a negative number in this case, because this is a and this is also actually what we're doing here is the same action, but we're taking the result, which, since we are dealing with a short, we're getting this representation, and it's interpreted by default as -4. But if we take this and we put it, casting it by force again to a short, to an unsigned short number, we'll get this number, which is the highest possible unsigned short number minus 4, I think. We can verify that. So, like we mentioned in the previous lesson, we have a fixed number of bytes, for example, for a short or for an int or for a float, and this can be representing an unsigned or a signed number according to the structure and according to which kind of variable we're putting it in. So if we take the result of that, which is by default going to be minus 4, and we put it into an unsigned short, that means that we're taking this data as it is and we're just representing it differently in the context of the program.
Well, one question. Casting is a binary operation. Just
casting doesn't change the value.
No, not. I meant that it takes the same binary structure of the number, but puts it in another format.
Mm-hmm. Yeah.
And reads from.
Yeah, that is actually the reason we have signed and unsigned numbers here, because they are represented the same, because the space is limited and it's used in the same way on the bit scale. But casting here is important so that we'll get the right representation of what we need, because what we got here changed our value from unsigned to signed. Questions about this?
Can we print binary numbers?
That's a classic interview question. Take a number and make it into its binary representation. Hmm? You can use, like in many computing programs, there's more than one way to do it. Yeah, that could be. Yeah, that will produce a string with a basis of 2. So, yeah, that's correct. Although, if you are asking about usually when you're asked to produce such a thing as an exercise or a question or a problem, you will be asked to do it in a different way, like to produce your own algorithm of how you take the number and what you make with it. One option, for example, is to use the bitwise operations and to take a mask. That means that we have, for example, the number 1. We start with the number 1, which puts the bit 1 on the rightmost side of the number. And then through a bitwise operation, we're pushing it all the time to the right, and we're checking the bits from right to left or from left to right. And we can check actually whether the bits are zeros or 1 in the original number, and we can produce from that the zeros or 1s to display on screen. So that's one option. Sorry, any more? Okay. Some of these we've already encountered. The equal comparison, which checks whether two values are equal to each other. Then we have the intuitive greater than or smaller than, or greater than or equal, or smaller than or equal. And this exclamation point again makes it its denotation is not. So in this case as well, we're checking whether two values are not equal to each other. So let's see it again in Visual Studio. So again, we have the two numbers 4 and 5, and pretty simply what we have here is a check whether A is greater or equal to B, or A is completely not equal to B. Okay, what will happen here? When?
The operation itself.
Mm-hmm.
Because it is before the B. The operation plus plus is before B. And it will assign the value of 5.
Mm-hmm. So B will become 5 before we check the condition. So first of all, B will become 5, and then we'll check whether A is not equal to B. And since now A is equal to B, we'll get a false here. And that's
But why the last one will be false?
because the value
Assign 5 before
B is already 5. This operator, the plus plus or minus minus, never, regardless of whether it comes before or after the variable, changes the value of the variable. So after this line, the value of B is already changed. We can see that B is now 5.
So it doesn't matter that it is inside also the right line.
No. Once you have, in any operation or in any other statement, once you have this, it changes the value of the variable itself. So on the next line, B is already changed. Now we have an assignment operators. First of all, the basic ones which we know, we take a value and assign it to a variable. And here we have a list of a few of the shorthand writings of taking an operation and doing it and assigning it at the same statement. For example, we have the value of y, which has been assigned to 4. If we go, I don't know if I can write during, oh, no. Let me stop the run for a second. This statement here that takes y and multiplies its value by 2 and takes the result and assigns it into y, is there actually what we have on this line? Instead of writing this, we can write it like this. So whenever you have an operation like this, which is just next to an equal sign, that means take the value that you have, make the operation on the value itself with what you have on the right side, and assign it back to your variable. That's why the result of this operation will be 8. And there is also the action of assignment. It's not just y times 2, it's also y times 2 and assign the value back into y. Yep.
Can I ask whether it's good to follow style because I was told by according to Fios that it's not a good style.
They are used a lot.
They're used a lot.
Yes.
Yeah, probably that they make the default quite more difficult.
No, operations such as this, you'll see quite a lot.
Okay, so I can use them.
Yes. Yes. I use them a lot, and I can tell you that there's no problem. I think that if someone complains about style of code that looks like this, then the problem is not the code. So that's what we have here. Uh-huh. We got overflowed number. Yeah, we have, what we got is an overflow. If we look at int.max value, what will this produce? Yeah. So we are taking it from the other end. In any case, the result here is overflowed on the integer. And if you are trying to cast a number larger than what your variable can contain, then you could be in trouble. That's the main conclusion. Okay. Any more experiments on this? Okay. Expressions are basically everything we've spoken about so far. Sorry, I'll check the time so we'll have a little time for you to get some coffee and revive yourself. But I think we are almost done with the presentation. Let me see. Yeah, we're getting close. So expressions are everything we've seen so far with variables and data types and numbers and operators and literal values. So what we see here are just examples of how to get an arithmetic calculation, and I don't see anything special here that we can point out. Again, we see here expressions which relate to arithmetic calculations between literal values or between literal values and variables. The precedence of the operators, as we mentioned, is something to note. Parentheses, everything we've spoken about. All these conditional, logical operations. So we can break it down into all the bits and pieces, but this is quite clear now, right? Okay, let's see the demo, which so arithmetic calculations, as we can see, parentheses take precedence. So the first thing we have is a calculation of subtraction, then we'll have the division, then we'll have the addition. So 130, 65, sorry, 130, 65 plus 5, 70. Here you have the value of pi, p. calculating actually square radius times p is the surface or the what's it called? I forgot. Perimeter. Yeah. Actually, this is the surface, I think. Perimeter is times are 2 times radius, right? Yeah, that's what we see here. Yeah. I don't think we need to explain much about this, right? Or about this. This is quite clear, right? If it's not, stop me. Here we have a complex check for a Boolean logical expression. So we're checking if A is equal and B is equal, then we take both of those, we do an AND to both of them, and with the result here we do an OR with an A greater than B. And the result here will be, of course, a Boolean true or false. In this case, false. So here we're taking the integer values and we're casting the result of a calculation between them into a double. So since we have 17 and 12, 30, and we're dividing by 12, we're getting a double number. If those were all integers and we were putting the result into an integer, we'd get a rounded result. And the difference here even though we are dividing, sorry, those are different numbers. Okay. One more thing to know about type conversions that you might want to know. There is a system function which is under the system namespace. There's a class called convert. And here there are many functions that you can call in order to change the variable's value from one type to another. So, for example, if we look at the int32, which is the representation of the int that we're using all the time, we'll see that we have 19 different options here of what we're sending this function. It could be a Boolean, byte, character, decimal, float. These things are safe to use and they're very useful unless you it's more safe than taking something and by force trying to cast it. So you should know that system.convert.to something is quite a useful function set. So, to recap, we've seen all the operators, we've seen a lot of variables and types, floating points and numbers. We've seen the bitwise operations and how they affect each other. We've seen all kinds of expressions throughout this presentation. I think that's about it for this presentation. Any more questions about this? A few more points that I would like to point out. Let's open a new project here. One thing mentioned I think in the first lesson is the structure of the code, and it's good to know that Visual Studio usually takes care of this by putting the tabs right. Tabs, I mean, in terms of how the text is aligned to the left or to the right. Probably you know or don't know that you can take a group of lines and you can play with the tab or shift tab button to move everything around. So that can save a lot of time. I've seen people doing some spacing with spacebar, and it's much neater and easier to use what Visual Studio gives us.
I think the best way is Control plus C plus D.
Which does what?
It's takes all your codes and
beautifies it.
formats it.
I didn't know that.
Not only left and right. So if you have written everything on one line, it will put it in many lines. It will make it more readable.
Control plus C plus D. I think it doesn't work on mine because there's another extension of Visual Studio that takes Control D. Hmm?
I think it depends on your configuration.
C, you don't press C and D at the same time. Key. Oh. Control K and then D. That's cool. I didn't know that. Second thing is to add comments to your code. I think it hasn't been mentioned in those presentations, but it's very important. As in C++, you have two options. One of them is the multi-line comment, which starts with a slash and star and ends with a star and slash. That's quite useful. The other option is to use the double slash, which takes effect only on a single line, just so that you know that it's important and it's good practice to comment your code. There's a third way of commenting, which is specific for this language in this environment, which is used on functions. For example, if I declare a function here, there's the triple slash, which creates a set of comments corresponding with my function, and that's important for our documentation, especially if you're working on a big project. There are also extensions to make this thing work better. There's something called Ghost Doc, which I think I have here. Yeah, which in one click, or maybe not. I think that something is overriding. Yeah, it gets you a comment and already fills the data of this function. So that's also quite useful. Another thing is that I'd like to point out is search for your code. The internet is full of results of implementations of pretty much any exercise and any problem that you may run into. One thing that I've seen in the previous lesson was a task that was to, for example, to print out the copyright sign, right? Which is produced by Unicode, and if I remember correctly, it was A9.
Yes.
Okay. So here's the small sample, and we've seen that actually it doesn't produce the copyright sign, but it produces C, right? So it took a little bit of research, and It's not a bug. It's the encoding of the console, and also the font of the console. So one thing here which doesn't work correctly is that we're using Unicode characters into our console, and by default it doesn't support it. And one way to make it work with Unicode support, console, is to set the output encoding. For example, to Unicode format. So this doesn't work very well. The reason is that this console is working with a set of fonts that doesn't support Unicode format. And if it had been using such fonts, we would see that we have here the copyright sign already appearing. So these things are not given and many times not specified in the presentations, but make a lot of research if you're looking for some kind of answer, how to implement this or that, or you see that things are not working. Google is your friend. And the second thing is that the work environment is your friend. Like I mentioned, nobody knows the MSDN library from start to finish. And what happens if this or that? Just try it out. I've been to a conference a couple of weeks ago with representatives from Microsoft, and as you know, the F1 button opens the help. In this case, it's the MSDN library of the whole framework. But he mentioned that F5, that starts a debugger, can give you much more information than F1. So that's a tip also to remember when you're working on those exercises. That's I think something that Svetlin was trying to point out in his first presentation on the first lesson. Just be explorative. That I can tell you from experience is a great deal of the life of any developer. A lot of Googling, a lot of copy pasting, and a lot of trial and error, and a lot of exploration of what you're trying to achieve. And with this note of inspiration, I think we'll get some coffee, and then we'll continue with some exercise time, and I'll be here to help. Unless somebody has a question. All right, so let's take a break, and we'll continue with